Hello, I'm Anjali. I'm a graduate student pursuing my master's in knowledge engineering at National University of Singapore. Today I'm going to demonstrate how a neural network works. All computers on the planet operate through algorithms, which are mathematical recipes that instruct a computer to complete a certain task. The difference between these algorithms and human intelligence is that algorithms are not adaptive, whereas human intelligence is. So in order to truly achieve artificial intelligence, computers have to think adaptively, and there have been many approaches to make computers more competitive against the human brain. One popular technique to generate artificial intelligence is in fact designed to work like the human brain and the nervous system. It's called artificial neural networks. So imagine that you stub your toe. There are sensory nerves in your foot that set off a chain reaction of signals that ultimately tells your brain that you just felt pain. Ideally, this is how neural networks should work. This program comprises of a series of branching nodes that operate much like the neurons in your body. Information is fed into the input nodes, which is then transmitted across the entire complex. This network then processes this information until it generates the desired output. So how is this done? Through neural networks are inspired by two essential components of the human brain, the neuron and the synapse. A neuron is a type of cell that processes the information that it receives from the other neurons. The synapse is the connection between neurons, allowing information to flow from one neuron to the other. These computer programs have their own version of each. In neural networks, the node acts like a neuron. It receives information, performs a qualitative function that transforms the information and sends it away. A synapse then carries this information from one node to the other and makes its own adjustments to the data as well. When a node sends out a signal, the synapse then modifies the information by multiplying the data by some constant value. This modifying step is called applying weight. A node can accumulate data from multiple synapse connections and adds up all this information together before processing it. Then, just like the synapses, they do and make adjustments to the data by multiplying it by value, and this is called the node bias. Our input data is subjected to weights and biases because this determines whether information is transmitted from one node to another. It acts like a checks and balances system. In order for one node to pass along the data, it needs to be activated first. Nodes are activated when its output is big enough to pass a certain threshold determined by the computer programmer. If your data reaches past a certain point, it will move on to the next node. If not, the node remains dormant. In this series of dormancy and activation, turning nodes on and off is what determines the ultimate product of your network, and this is how networks tell the difference between pictures of dogs and cats, apples and tomatoes, etc. But what if the final product isn't what you wanted? What if your neural network accidentally claims the dog to be a cat? If the output leaves something to be desired, the neural network uses an algorithm called backpropagation to go back and adjust its weights and biases, fine-tuning its nodes and synapses little by little until it is closer to the correct result. And as it gets more data and feedback, the neural network gets more accurate from this basic model. Now we look at some applications of artificial neural networks. Computer programmers can train neural networks to be better chess players, or to recognize voices, or to identify text, or classify images. The business applications of artificial neural networks are fraud detection, credit scoring, forecasting sales, economic tuning points, targeted marketing, stock exchange prediction, etc. This is a very simple model, though as most neural networks contain thousands of neurons that have formed millions of connections. And yet, even the most sophisticated neural network are still nowhere near to the human brain, that is close to 100 billion neurons. Thank you for watching.